This presentation discusses cloud computing fundamentals, addressing specific objectives that are also covered on the Google Cloud Digital Leader exam. In this lesson, we will explore the fundamentals of cloud computing and will specifically address the following exam objectives. 1. Describe the differences between cloud technology and traditional or on-premises technology. 2. Explain the benefits of cloud technology to a business digital transformation. This technology is scalable, flexible, agile, secure, cost-effective, and offers strategic value. 3. Describe the primary benefits of on-premises infrastructure, public cloud, private cloud, hybrid cloud, and multi-cloud, and differentiate between them. 4. Define infrastructure as a service, define platform as a service, and software as a service. I know you're excited to learn about these topics, so let's begin. Businesses have an insatiable need for technology. This is because it's the tools and applications of our modern age that allow business to form relationships with customers. Businesses must create value, and they do this by opening new markets or by enhancing their engagements with current ones.
In a digitally connected world, it's applications that serve as our conduit between business and customer. As new markets emerge and existing ones evolve, technology opens new doors and allows businesses to compete and remain relevant.
Technology is fluid and ever-changing. Adopting technology can bring great benefits. Yet, operating solutions comes at a cost, complicated by constant change and the threat of competition.
In practice, technology creates a sometimes chaotic tapestry, and progress doesn't follow a linear progression. Businesses seek technology to engage with customers, because to remain competitive, they must.
However, technology creates an ever-present need, which a business must constantly navigate. Just like when there's smoke, there's fire. The presence of a technology solution implies hardware and the infrastructure to house it, along with a whole range of management logistics.
In the earliest days of enterprise computing, when technology options were far more limited, businesses purchased hardware, found a room to place the equipment, and got to work by installing applications and tools directly on the hardware.
These early technology environments saw entire hardware solutions dedicated to a singular purpose, with very low opportunities to share. These environments were highly isolated. Each of the hardware and software components were dedicated entirely to singular roles.
As the demand for apps grew, physical space to house the required infrastructure became premium. One of the early motivators for change was the cost of housing physical hardware. New solutions were being invented all of the time, but businesses were running out of space to fit everything.
Furthermore, managing technology environments necessitates specialization. Operating hardware at scale not only entails addressing diverse technical demands like power and cooling, but also necessitates businesses to establish processes for physical access and routine maintenance.
The initial capital costs associated with such technology, particularly for hardware, poses a considerable barrier for many small businesses. Businesses found themselves bogged down in technology concerns.
For example, In order to avoid a multi-day outage on your business, you need robust power and cooling systems. To ensure that environments remain up to date with cutting-edge technology might itself cause an unavoidable 3-day outage.
To remain competitive in the modern era, businesses truly need to focus on core values. Yet, for a lot of business, the nuanced concerns of technology is a major distraction. Scheduling server reboots or increasing storage capacity are important. But for many businesses, such activities fall beyond the scope of where they truly need to be focused. Organizations began to find value in the concept of co-location, which replaced the oldest of models of hardware self-hosting. By sharing infrastructure, businesses could begin to hire specialists, opening new opportunities to outsource mundane concerns like infrastructure, power, cooling, and physical access. It led to the onset of service provider specialists, who began offering infrastructure management services at scale.
In the co-location model, businesses retain ownership and responsibility for their technology assets. However, they contract the care and operation of these environments to third-party providers. It's like owning a home. As a homeowner, it's our responsibility to fix pipes or replace a roof, but in many cases, we outsource that work to specialists. And in the case of enterprise computing, it's technology specialists who maintain our hardware infrastructure.
Co-location provided businesses with suitable space for their hardware, yet it didn't fully address technology's challenges. In this era of enterprise computing, applications remain directly linked to physical hardware. In such a model, making improvements like adding memory or increasing storage causes application downtime. Such outages are undesirable as they affect business operations and the customer experience.
Businesses aimed to break the one-to-one connection shared between physical hardware and the applications they provided. Costs associated with procuring upgrades and the downtime to implement are the most substantial when dealing with physical hardware systems. For this reason, businesses sought to minimize the hardware changes. And they accomplished this using a new paradigm called virtualization.
Virtualization in computing allows a single physical machine to be partitioned into multiple virtual ones. This impact is profound because it goes far to solve the problem of the ever-growing hardware footprint. Instead of isolating hardware within solutions, businesses could provision virtual machines instead.
Virtual machines are maintained by a hypervisor, which runs on physical hardware. A hypervisor facilitates and provisions virtual machines, which appear with all of the characteristics of a physical one. Key to the technology is the fact we can have many virtual machines running within a single hypervisor. In the virtualization model, businesses deploy virtual instead of physical machines to applications and developers. By leveraging VM technology, businesses could begin making significant investments in hardware and then share this infrastructure across a broad range of application use cases.
Virtualization lays the foundation for private clouds. These clouds enable users to independently allocate virtual resources, such as computing power and storage, over networks or the internet. With a private cloud, teams no longer have to endure lengthy waits for resource procurement. Instead, they can quickly adapt to changing needs. The advancement of high-speed networks serves as a critical link in this process, allowing for the swift and self-directed provisioning of virtual resources.
Private cloud architecture furthers the separations between application and hardware, leading to additional specialization opportunities. Infrastructure management became a discipline, freeing application developers to focus on coding and features. The same specialists who provided co-location services in previous epochs evolved to offer a new product, called infrastructure as a service.
Importantly, application developers are separated from hardware's concerns. The highly paid data scientist can focus on creating quality insights and not on the next round of operating system patches. Your seasoned data expert can spend time working on insights, instead of dealing with underlying storage problems. When businesses want maximum degree of control and complete exclusivity, they turn to the private cloud model, which is still very much in use today. Private clouds allow businesses to create dynamic environments, an environment where virtual machines exist for precisely as long as they need to, before being relinquished back into the virtual ether.
Private clouds are still used by enterprise when they need to maximize control over their infrastructure, which is often the case in regulated industries. Private clouds offer the flexibility of virtual machines while retaining control over all aspects of the technology operation. While private clouds optimize hardware concerns, what if we had no hardware concerns at all? The next great innovation we discuss are public clouds. World-class providers like Microsoft, Amazon, and Google have taken the concept of private clouds a step further.
Public clouds offer virtualized technology resources over the internet, but without the need to maintain any underlying hardware. This is a democratization of technology that has the potential to change the world. Businesses big and small are now untethered from hardware's concerns and instead are free to leverage infrastructure services through a model known as pay-as-you-go.
Public cloud architecture like that found within Google Cloud Platform is considered a key enabler of digital transformation. Public cloud is supported by world-class experts, those who instinctively seek to create more engaging customer experiences. In today's world, it means streamlining the technology concerns like agility, flexibility, scalability, and reliability into cost-effective infrastructure solutions. While some use cases require private cloud architecture, there are often situations where businesses can benefit from implementing both private and public cloud resources. For example, highly critical payment card industry technology may remain on-premise, while the company's corporate website might be moved to public cloud infrastructure.
Hybrid clouds exemplify the flexibility of modern cloud environments. This creates multi-cloud environments, which are those that can consume resources from any number of cloud providers.
A client may decide to run database services from Azure and a VM from Amazon.
Multi-cloud is an architecture that avoids vendor lock-in.
The flexibility of modern clouds allows customers to cherry-pick, selecting just the technology services they like. and thus creating the potential for a rich tapestry of technology solutions built upon the strategic selection of innovative capabilities of the modern public cloud.
When businesses shift to the public cloud, they move away from costly on-premise setups. Utilizing public cloud resources allows an organization to embrace new opportunities for technology management. Using the cloud, businesses gain significant outsourcing opportunities, allowing them to outsource mundane and distracting infrastructure concerns.
When businesses opt to leverage public cloud, it's like moving from an old home we own to renting an apartment. As we move to the apartment building, or in our case, the cloud, we begin to leverage shared services. But at home, we're compelled to deal with all of the infrastructure problems ourselves. As we move to the apartment building, or in our case, the cloud, we begin to leverage shared services. In this analogy, we're still responsible for our room interior, but someone else will keep the public hallways clean, and someone else will come to fix the leaky pipes. It's the same for cloud providers, who offer infrastructure benefits at scale. To help highlight the significance of cloud adoption, we'll explore a classic use case: the need for a website. We'll keep our example simple. A website needs a few key parts: networking, storage, and a server to run on.
If we build a website on-prem, we must accept the consequences of operating our technology. Building a website in the self-hosting model means accounting for each of the concerns in the technology stack. We'll need to invest in the right kind of room, with the necessary power and cooling.
In fact, we'll have to procure a lot of equipment, including storage, networking, and endless cables. Then, we have to hire experts to set it all up for us. And all of this must occur in advance of our first customer engagement.
Now, let's look at what happens in our website scenario when we move to the cloud. The first big advantage is we get to sidestep a huge initial capital investment. Instead of having to build the right room and purchase hardware, we simply leverage cloud pay-as-you-go resources instead. This infrastructure hosting model is flexible, and virtual machines procured within it are intended to scale, allowing our website to start small and grow later as required.
Cloud's ability to help us right-size our workloads is a major improvement. Prior to the cloud, systems were built, at onset, for maximum peak usage, despite the fact the growth may be some time into the future. Infrastructure as a service is known as a service model, which is actually in a whole category of service models. A service model works with our chosen deployment model. Recall in previous videos we discussed that deployment models can be on-premise, private cloud, public cloud, or hybrid cloud. Different service models help to describe the division of responsibility between us and the provider. One of the more well-understood service models is IaaS. And at the heart of most infrastructure as a service configurations is the virtual machine, or VM.
Creating virtual machines in public cloud environments such as Amazon Web Services or Google Cloud Platform provides us with a familiar server with all of the features of a physical one. As businesses deploy to virtual machines in the cloud, they forego the need to make hefty upfront capital investments of their own. Moreover, cloud environments are by nature dynamic. This makes provisioning and even deprovisioning much faster compared to traditional hardware procurement processes.
So in short, infrastructure as a service is a way to rent the amount of scalable infrastructure necessary to run and operate virtual servers. Google Cloud Platform Compute Engine is a powerful infrastructure as a service offering.
Compute Engine is said to be a managed service because the underlying infrastructure concerns are abstracted away. However, it's important to know that Compute Engine is not the only managed service that Google and the public cloud giants provide.
This is when we begin to see that cloud technology is not simply just the next big upgrade, but rather a giant leap forward in strategic technology management. Beyond infrastructure, cloud providers like Google Cloud Platform also offer a service model known as Platform as a Service. This service model extends the offer to include features that go beyond those found within the infrastructure as a service model.
In particular, Platform as a Service managed services handle most, if not all, of the server-related tasks. The level of management varies by service. For example, App Engine Standard is fully serverless, so you don't worry about servers at all. App Engine Flexible and Cloud SQL, however, require you to choose server sizes and configurations, but they still handle many management tasks for you. Google Cloud App Engine is a great example. By leveraging App Engine, we focus on the code instead of meddling with underlying technology issues. Patching and configuring servers is abstracted away, leaving us with a runtime environment capable of recognizing many of the standard programming languages. For example, web developers can build their websites using familiar, industry-recognized code frameworks and expect the code to run within these managed sandbox environments. Another example relates to databases. Developers who need database services could opt for a managed database service operating in the public cloud. Google Cloud SQL is a platform as a service offering that significantly minimizes server administration tasks. By abstracting away underlying infrastructure management, we're able to leverage familiar database features without worrying about underlying hardware provisioning, patching, or maintenance.
By bundling these concerns into a managed service offering like Cloud SQL, providers such as Google offer services that can significantly reduce the time it takes to provision an application or database service. They also free us from committing to high upfront capital expenses. By understanding these motives, we begin to truly understand the flexibility that modern cloud brings to any business seeking to undergo digital transformation. Another service model is known as software as a service. Think about your favorite web apps like YouTube or Gmail. For many businesses, particularly those without a software development focus, software as a service offers a fully managed alternative. There is no application to install and no servers to configure.
In software as a service models, all of the concerns are handled by the provider. Recently, additional service models have gained popularity, each catering to specific business needs.
Two notable examples are container as a service, known as CaaS, and function as a service, or FaaS. The container as a service simplifies the deployment and management of containerized applications. Containers offer a lightweight, efficient way to run applications consistently across different environments. Google Kubernetes Engine, or GKE, is a prime example of a CaaS offering.
GKE allows businesses to run containerized applications with ease. The service manages orchestration, scaling, and operations without us having to worry about the underlying infrastructure. This model provides developers with the flexibility to build and deploy applications rapidly while ensuring they are portable and scalable.
On the other hand, function as a service enables businesses to run individual functions or pieces of code in response to events without managing servers. This serverless computing model allows developers to focus solely on writing code, while the cloud provider handles execution and scaling. Google Cloud Functions is an example of a FaaS offering. It allows businesses to run event-driven code in the cloud. The service handles automatic scaling and managing the infrastructure. This model is particularly useful for microservices, real-time data processing, and building APIs.
In summary, the shift to the public cloud deployment model allows an organization to adopt new and innovative service models. By leveraging infrastructure as a service, platform as a service, software as a service, container as a service, and function as a service, organizations can significantly reduce upfront costs, streamline operations, and scale their applications with unprecedented flexibility and efficiency.
These managed services allow businesses to focus on their core competencies, innovate rapidly, and respond to market demands with agility. As cloud technology continues to evolve, it opens new horizons for strategic technology management, making it not just an upgrade, but a central element found at the core of the drive towards success in the digital age.
Embracing these cloud services is akin to moving from the constraints of an old home to the limitless possibilities of a well-managed, vibrant city apartment, where the heavy lifting of infrastructure and platform management is expertly handled. Leaving businesses free to flourish and grow.